Hello class, so in this video we're going to be talking about the third integration technique called improper integrals. Okay, so what are they? When do we use them? How do we apply them? So we need to use them if the limits of integration are either one or both of them is infinite or outside of the integrand's domain. So remember, integrand is the thing inside here, so basically if that becomes undefined through one of the limits, then you have to use an improper integral, because that's what that is. Alright, so we would basically replace the bad limit, or both of them, with a variable or two. I like to use t. Some books use a lowercase b. I'm not quite sure why, because that could look like a 6 if you're writing fast. So I would suggest t or something unambiguous like that. Then use a limit, so the limit as t approaches whatever the bad limit is, and then evaluate the integral as it normally is. So let's look at how this works. So let's evaluate this one. First, limit as t approaches infinity, and we're going to replace that top limit of integration. And then let's see, we can u sub this. So let u equal ln of x, du equals 1 over x dx. Then we get the limit as t approaches infinity of, let's see, ln of e is 1, ln of t is ln of t, of, let's see, that'll be 1 over u squared du. Okay, so that's going to be u to the negative 1 over negative 1 from 1 to ln of t, and we can actually just switch that to make it a little bit easier and to just get rid of the negative, because why not? 1 over u to the ln from ln of t to 1. Alright, so then we get the limit as t approaches infinity of 1 over 1 is just 1, and 1 over ln of t. That's going to approach 0, this part. Reason is because ln is a monotonically increasing function, so gonna get bigger and bigger. 1 over bigger number approaches 0, so we just get 1. That means that we have a value for the integral. In other words, the integral converges. If it didn't, so that basically just means it equals a number. If it didn't, then we would have what's called a divergent one, so it would diverge rather than converge. Alright, so let's look at this then and start working with it. Okay, so limit as t approaches infinity of the integral from 1 to t of x to the negative p dx. Just evaluate it like normal. So add 1 to that. So I'm just going to put the 1 in front rather than in behind it, like negative p plus 1 just makes it look nicer. Okay, and then I'll move the 1 over 1 minus p to the front. Limit as t approaches infinity of x to 1 minus p evaluated from 1 to t. Okay, what that's going to give us then is this. T to the 1 minus p minus, and then if we just replace x with 1, we just have 1 anyway. So the question is, when does this converge and diverge? Converge. Essentially, if this power is less than 0, so a negative power, remember that's going to give you a exponential function that's decreasing. Converge. Diverge is if that is greater than 0. What about if it's equal to 0? Well, if it's equal to 0, then this thing becomes undefined, right? So we can't exactly have that. So we can say if p is less than 1, then, oh, greater than 1, sorry. If p is greater than 1, then the function is going to converge. Versus if p is less than or equal to 1, then it's going to diverge. So that's what's happening in this little thing. This is also called the p-test. All right, let's try this one then. So the limit as t approaches infinity of the integral from 1 to t of 1 over 2x plus 1 squared dx. Okay, how can we integrate this? I guess use substitution. All right. So then with this, we get, okay, so there's going to be a factor of 1/2 going in front, so I'm going to put it way in front. Limit as t approaches infinity of the integral from, oh yeah, we got to replace that. So 2 times 1 is 2, plus 1 is 3. And then 2t plus 1. 1 over u squared du. Coincidentally, the same thing that we got up there, basically. Limit as t approaches infinity of u to the negative 1 over negative 1. From 3 to 2t plus 1. I'm just going to change that again like I did with the one up there. 1 over u from 2t plus 1 to 3. Alright, and then we get 1/3 minus 1 over 2t plus 1. And this is going to go to 0. Then what we get is, let's see, 1/2 times 1/3 is 1/6. So this integral also converges. Alright, so that's the end of this. Hopefully it was helpful, and I'll see you guys later in the next video.